Hello YouTube, XCT here. Today we are solving proper, a 40-point Windows machine on HackTheBox created by JKR and me. This box involves a custom SQL injection and a remote file inclusion that is quite tricky to exploit. Root is about a custom service binary running a system and requires some light Golang reversing and knowledge about Windows internals. So after the port scan, you'll see that there's basically only port 80 open, so let's have a look at this website. So here we have some company's website, which mainly has products that help you clean up your operating system. And those of you who are a bit older might remember them. A long time ago, these were kind of popular, and you would have a tool that like frees up your RAM and stuff like that. And there's some information on these tools here. But the really interesting stuff is happening in Burp. So let's have a look at Burp here. And you can see a couple of requests, but one is a bit more interesting than the others because here we have some parameters. There's an order parameter which takes ID plus desk, and then we have this age parameter which looks like an MD5 hash. So let's play a bit with that. Right, that's the normal one. Let's this order looks like what you have in a SQL database, right? You can order in ascending or descending direction. So let's try to change that to ascending. But then we get an error like there's tampering detected. So there's some kind of mechanism which prevents to just change these parameters, right? Let's change that back. Change this age parameter as well. And here we get the same thing. What if we just omit this parameter altogether? Then we get an error and actually an error message, which is quite interesting. It's telling us that there's a salt, which is this value here. And it wants the order and the age parameter. So with this information, we can kind of guess that this might be like a checksum for whatever is in the order parameter. And from the last request, we saw that there's some salt involved in calculating the checksum. So it isn't just the MD5 hash of that, it's the salt somehow combined with the MD5 hash. So let's play a bit with that. So you have multiple options here. You could either append the salt or prepend it. So let's try the prepend way first. And in the default request, we had ID and descending. So let's try that, ID and descending. And I'm putting a space here because that's just an URL encoded space here. All right. And now let's take the MD5 sum. And if we look at the value in the original request, you can see that this is actually the same one we just calculated. So if we were to change that to ascending here, we get a new hash. Let's put that here. And also let's change that to ascending. And now we get no error. So this has worked. So we can change this parameter now without messing up and without triggering this tampering detected message, right? So what if we were to put in, say, just a double quote here, place the hash, put that here, actually without the space, and we get an internal server error. This is kind of interesting and kind of goes in the direction I've been mentioning earlier, that this is probably used in a SQL statement, and we have some kind of SQL injection here. And also this parameter named order suggests that this might be in the order by part of a SQL clause. And SQLMap can actually exploit this, but we have to somehow give it an idea how to calculate this age parameter, because if that's wrong, we just get the tampering message and we won't get anywhere, right? So now let's try to solve that with SQLMap. First of all, let's take the request we saw at the beginning, just give it to SQLMap with -u. And now there's a trick you can use here. You can use -- eval and Then you can put some Python code here, and that will actually evaluate the code. And if you assign a value to, in this case, age, it will use it in every request. What we're going to do is we are going to construct the MD5 hash we need here dynamically on every request. So let's import hashlib to calculate the hash. Then we want to put the salt here. And this should be good. Basically, like I said, we're taking hashlib, using it to calculate the MD5 value of our salt, concatenated with the value in order, and we are assigning it to age. And this will be evaluated on every request. So it should solve our problem. Let's give it a few threads, and we want to output all databases. And here it already found the type of injection. Found that in order we have a Boolean-based blind injection. And here we go, it finished. You can see we have a Boolean-based blind or time-based blind injection, and it actually dumped us 3 databases. Now let's run that again, but this time we want to dump the cleaner database and we want to see all the tables. So there's customers, licenses, and products. And now finally, we can use the same thing again to go to the cleaner database, to the customers table, and dump all the customer information. And we can already see that there's a password column here. So there will probably be some kind of endpoint where we can log in. So while this is running, I'm going to start an fhuff here, which is just going to the web root with a large directories word list. Let's stop that here. What I wanted to find is this licenses endpoint. And here we got an actual login. So if we can crack one of these hashes here, we should be able to log into the area. So it has finished. That took quite a while, and you don't actually have to dump everything, right? You can just take the first user, crack the hash, and you will be able to log in. But if you run it to the end, you can actually use SQLMap to crack the passwords because they're really easy. So let's just take that one. And try to log in. And here we go, it worked, and we are in this private area. So now that we are logged in, we can sort of do the same thing again. Let's look in burp if there are any unusual requests. Doesn't seem there is any so far, so let's make it full screen. And here we can see that there are several themes we can select from. So let's use the solar one. And let's see what happened in burp. We got this request to licenses.php. It's loading the solar theme, and it's again calculating the same hash we saw earlier, and we can confirm that by just using printf again here. Let's put solar here, and we get 18a and so on. And that's exactly the same hash we have here. So let's try to put something else here. And now we get an error. Let's see. It's telling us that there's no such file or directory. And it's also telling us what it tried to do. It's doing a file get contents on the thing we give it as a parameter. It treats this as a folder and then looks for header.inc inside that folder. So we could potentially point it to local files, but they would have to sort of end in header.inc. So it wouldn't really help that much, I guess. And also there's some stuff here about the secure include. And this is actually checking the file that is included for a PHP open tag. And only if it doesn't find one, it will include the file. Additionally, we can see the web root here. So there's some path disclosure. But other than that, that's basically it. And if you are familiar with PHP, you will know that file get contents can open from various different locations. It can take a URL, it can take UNC path. So we have some options here. Let's first just try to give it a URL. So create a folder here, create a web server, and try to give it a URL here. So now it's telling us HTTP request failed. But we did actually get a hit here. But of course, this file and folder doesn't exist. So let's create it. Send that again. And this time we get another error message. And now it's telling us that the HTTP wrapper is disabled. So we are not allowed to include a URL. So the idea was good, but we are not allowed to do it like that. So as I mentioned earlier, what we can do instead is we can also give it a UNC path. So let's use SMB server.py from Impacket here and create a share. And actually my Impacket seems to have a few issues, so let me change that. Here we go. And now let's try to give it a UNC path like that. And of course, we also have to update the hash again. And now we got this tempering message again. And this is quite tricky to see, but we have a /t here and printf will fuck that up. So let's just call our folder something else. Just say it's called xct. Start that again. Take the new hash. And it's still not working. So let's explore that a bit more. And I think we actually have to escape that. So let's do that. And now this looks better. It seems to hang. So yeah, we can see it connects to our server with some user called web. There's again an error. Okay, this time we don't have the header inc file there. So let's create that. We can see the requests again. And now we get an invalid argument error. So this isn't quite working yet. But we also get this hash here. So why not try to crack it, right? Let's paste that here. Let's choose John rock.txt on the hash. And here we go. We can actually crack the hash. But as you saw in the beginning, there are no other open ports besides 80. So you can't just, I don't know, use WinRM or something to connect to the box. So one issue that is a bit tricky to find here, but I think it's a pretty nice twist, is that modern Windows won't just connect anymore to shares that don't require authentication. This is something that was changed, I think, in Windows 10 or Server 2019. I think it's on both. And basically, Windows will only connect if it can use credentials, and these credentials are valid. But as you saw, we just cracked the hash, so it won't be a problem for us to just make an authenticated share, right? So now we should have an authenticated share. Let's try that again. And this time we can see that the authentication worked. And we can also see the contents of our file, which is pretty great. So the include actually worked. So the last issue remaining is that we still have this filter, which is going for PHP tags. If you go in here and put some PHP here, we should get an error if we try that again. And we get this tempering message. So it requested the file, but since it has the PHP tag in there, it won't really execute the PHP. And let me just paste that snippet here again we saw earlier in the error. You can see that this uses file get contents to check if the tag is in there. And file get contents is opening the file and closing it again. And then it does an include, which is also opening the file. So there's a check here, and at the time it's used, it will be opened again. So the check is not really guarding this include here, only in some sort of way, right? It's two requests. So if on the first request it wouldn't contain this tag, we would just be able to include it, even though it would include the tag here. So the question is, can we make our server side respond differently on the first and second request? So on the first, it doesn't have the tag, but on the second, it does. Before we do anything, let's prepare our listener and our reverse shell. So we have an XC listener here. And here we have our XC payload. And now we have to think about this time of check, time of use issue I just explained. So first of all, let's create a file. I'm just going to do it with dd here so it has some size, which is called header.inc.big. And it's basically just a bunch of zeros, but it's a big file, right? It's 10 megabytes here. Also, on the other hand, let's create the file that will contain our real payload. And I'm just going to call that one header.inc. Move that and now do the same thing as before, but I added a system call which would request a file from the SMB share, which is the reverse shell, right? So now we have these two files here, and we have to make sure that on the first request, it just requests this header.inc.big, and then the second one, our actual payload. So let's actually rename that. Maybe just to pwn.inc, so we don't mess up the original. And now we're going to copy the big one into header.inc. That's the one that will be requested. And we do a inotifywait on this file. This means that an event is triggered when this file is accessed for the first time. And when this happens, we do a sleep. Let's just say 2 seconds. Because the file is pretty big, it will take a while to request it. And then we copy our other file into header.inc so that the next request will get the malicious one, right? And it seems I don't have it installed, so let's do that quickly. Let's try that again. And remember, now we serve this big file, we wait for the request, and as soon as it is requested, we sleep for 2 seconds and then replace it with the other file. So let's try that. Our file got opened, but we get the tampering message. And this can happen because we have to play a bit with the sleep value, right? Because like I said, there's a big file requested. And before that request is finished, we have to replace it with our own. So the sleep value is something you have to play a bit with. And here we go, it actually worked. And as you can see, we really have to play a bit with the sleep value, or if you wish, with the size of the big header, right? So let's see. Now we are the web user. No special privilege list, but we should be able to get the flag, right? And here we go, we can read the user flag. So let's have a look at root here. First, let's enter PowerShell. And then let's download the privilege escalation script from our box. And here we go. Let's run it. So let's see if there's anything interesting. We don't have any special permissions. This is interesting. There's a service called cleanup, and it was installed with an ssm.txt, which is the non-sucking service manager and a quick help basically to install a normal program as a service without having to follow the structure you normally would have to. Other than that, it hasn't found too much yet. All right, now we could also run the extended check, which usually has some more interesting results, but let's just stick to the intended path for now. So we had the service. Let's call it like that. If you do it from PowerShell, we'll actually try to create the file or something. But we don't have access to get any details from the service. So let's explore the box a bit. Let's go to program data here. There's a cleanup folder. It's pretty interesting, but it's empty. Okay, let's go back. Let's go to program files. And here we have NSSM. And we have also a cleanup folder. Now, so let's go into that one. And here we have a README and two executables. So let's first read the README. It's saying we find the garbage in our system and delete it. And if you think back to the website, this was kind of the products this company is offering. So now we have the actual product here. And it's some alpha release. It doesn't have a GUI yet because it's a to-do. And it says to check additional paths. So I guess it's only checking one or just a subset at the moment. And yeah, now we have to kind of figure out what these two executables are doing. The server.exe is probably the thing we saw running as a service. That's a pretty fair assumption, I guess. And the client would be some kind of client component that interacts with the service. And usually how this is done is via some kind of inter-process communication, name pipes or something like that, right? So let's just try to execute the client and see if it does anything. And it's telling us that it's cleaning, whatever that means, the downloads directory. Let's see if there are any files in there. Okay, there are none, but we could try to create one. We should be able to list the contents again and have a file there. And let's run the client again. Okay, it says it's cleaning the directory, but if we do a directory listing, we see that the file is still there. So we have to do some kind of analysis there to get an idea what's really happening. So let's first start by analyzing the client.exe file. And I'm using the freeware of IDA here because we need version 7.6 to have Golang support. Alternatively, you can use Ghidra with the plugin for Golang, because I think when the box was released, this specific version of IDA didn't exist yet. So let's have a look here. You can see it takes some command line arguments. And this is actually pretty interesting. It's comparing it to 522D. This is ASCII, so we can put this into CyberChef and we can see that this is -R just reversed. So there is a -R option. And this is pretty interesting because we didn't see that option before when we just run the binary. Let's see what else. There's a string here as well. Let's see what that is. CLEA, so this is probably clean. Yeah, there's the N. See some string manipulation. And then we have basically two functions. We have main_clean and main_restore. And clean is the thing we saw when we just started the binary. It would just go to the folder and try to clean it, right? But it didn't quite work. And there's also restore, which is probably triggered with the -R option. So let's look at clean. It's reading a directory here, printing some stuff. And here we have a call to time.now. So there's some time measuring involved, I guess. And there's also an OS stat. And stat is getting some information about the file related to time. So we learned that basically if it goes through all the files in a directory and then it's stating them, getting the timestamps of the file. And it's comparing it to some value to determine if the file needs to be cleaned or not. And I know this is really tricky to see in IDA here, right? Here we have a call to main_service clean, and this is probably the case when it worked, right? When the time is like the program expects it to be. Let's see about that value. So if you convert that to decimal, we see that it's a interesting number. So basically what this number means is that we have this amount of seconds and it's basically checking if the file is older than 30 days. So that's the whole magic there. You put a file there and if it's older than 30 days, this file will be deleted. And the client binary can't delete it itself because it's running with user permissions. So to delete it, it's calling into the service with this main_service clean function here. And we can see that there's some name pipe action going on here. So the client binary and the service binary are communicating with a named pipe. But it's not really easy to see what is transferred over the pipe here, right? If you were interested in that, you would have to run it and monitor the actual pipe. So let's also look at the restore function here. See if we can find anything interesting here. We already saw it's -r to trigger, and it's more or less straight calling into the service here. And again, the stuff we can see ends in the named pipe. So now we have to look at the service, at the server.exe instead. So now I got the server.exe open. Let's see. We have clean and restore again. Let's look at clean first. See if we can find anything interesting. It seems to read the file before it deletes it. It seems to do some kind of hex encoding. Base 64, it's interesting. It's using some restore path, so this looks like the program is doing a backup of the file before deleting it. So let's look a bit further. Yeah, and then it's basically doing write file, so it will write the backup to some place before it actually calls os.remove to remove the file, right? And also, it looks like maybe there's some cryptography stuff going on here. Let's look at the restore function. Here we have the base 64 again. And here we also have a call or a reference to main_key and main_decrypt. So it's safe to say that the files are not gone for good. They are encrypted, encoded, and put somewhere on disk in case you want to restore them. And the key is probably in the binary, right? It has to get it from somewhere. So we might be able to decrypt stuff if we wanted to. And there's also this call to main.decrypt. And here we can see that actually AES is used for the encryption stuff. GCM with nonce. You could reverse that if you wanted to, but it's just a default Golang AES encryption, so it's really nothing special. So I think at this point we got a pretty good idea what all of this stuff is doing, right? So if we were to put a file into downloads that's older than 30 days, the service would go and delete it and also make a backup of the file. And then there's also this restore functionality, which would allow you to restore it to the original location. So let's see if we can actually get us to delete the file, right? So let's first create a file in the downloads folder. Let's see if it actually managed to do that. Okay, our file exists, and now we try to change the timestamp, and we can just use PowerShell for that. So we do it like that. We do a get item on the file, and then we can use .creationTime to change the timestamp. And I'm also changing last access and last write time because we didn't really see which of the timestamps the program uses, right? And remember, in program data, there was also a cleanup directory. And it's interesting that there's now a file in there, right? We didn't even trigger the delete yet, but we did earlier. And in the downloads folder, it appears that there was a file actually. We just didn't see it because it was hidden. This is pretty interesting. This is a base64 encoded file. So let's see what that actually means. And yeah, we can see that in downloads there was a desktop.ini file, and this is what has been deleted when we first run the binary. So we see that before it deletes the files, this is actually the place where it puts them. So this is the file we deleted. And remember, this deletion and restore process thing is being executed as system because it's being done by the service binary. But let's actually try to delete the file we just manipulated as well. So let's do client.exe, saying it's cleaning. So let's check the cleanup directory again. And here we can see the backup of the other file, which we just created and manipulated the timestamp of. This is our test file, as you can see. And here we are in program data, remember that. So we should be able to, if no one explicitly changed permissions, to create files here, like test.xct. And this is pretty interesting from the perspective that we are now able to also change the file names here. So we can delete a file, so it gets backupped here, and we can change the file name. So we could just put a path here that points to the Windows directory, and when we restore the full file, it would probably get restored there because the service is running a system and has the permissions to do so. And maybe as a final step, let's try to read the file. But as we saw in the reversing step, this is an encrypted file. And it's stored here hex encoded and encrypted. So we have no chance to get the content here. Let's actually see if we can also restore it. So let's run it and give it the path we saw here. Let's see if it's back in the downloads directory. And it's indeed back. Let's check program data, see if it's gone there as well. All right, that worked. We can delete and restore files, and this is being done with system privileges. So now essentially we have this privileged file write where we can delete and restore into an arbitrary location, for example, the system32 folder in Windows. So we should be able to write any DLL there, and there are a couple of ways to exploit such a privileged file write. And one of them is the USO DLL loader, which is this project here by Itman. And when the box was released, it already said here that this track is no longer working on Insider Preview, but on the box it should still work. And I think when it was released, it didn't work because HackTheBox didn't purge the pending updates. But I think on the current version, it should actually work. And if it doesn't, there are a couple of other ways to exploit such a privileged file write. So this one is using the update session orchestrator. And basically this targets the update scan process. And if we put a non-existing DLL there, which is called Windows Core Device Info.dll, it will execute. In this case, I think the default payload is creating a bind shell on some port. And if we look at the instructions here, it says we have to build it, and then we have this exe file and the DLL. So here we have this DLL. It's calling a create backdoor function, which is this one, and it's running a bind shell on port 1337. Maybe let's change that to 2000. And there's this bindshell.cpp file. Yeah, which is basically just creating the bind shell. So we build both of them, and then we copy them over to our HackTheBox. So let's upload these two files. And now let's actually drop into PowerShell. And let's copy this file into the downloads directory. Here we go. Okay, so now we have to do the timestamp thing again, right? So the binary actually deletes them because it thinks they need to be cleaned. So I'm just going to copy that here. Let's call our cleanup binary. Here we go. It cleaned our files. At least we hope so. Let's see if it's really gone from the downloads directory. Yep, that's the case. Let's look in program data cleanup if it appeared. And here we go. Our file did indeed appear. Let's decode that. And this is the path we expected, right? So now we want to change this file name into the one that points to Windows System 32, right? So we take that one and base64 encode it. And now we have the correct base64 file name. So let's copy that and list that again. And now we got the old path, but also the new path in there. And now we should be able to restore it into system 32. So let's try to restore that. It's telling us that it's restoring it, but let's confirm that. So the file is gone here, so it did something, but let's actually check if it arrived at the destination. And the shell died here. And this can happen from time to time because this shell is started by the PHP request and it can eventually time out. So if that happens, just restart the shell. It's not too hard. Just run this inotify line again and click send on burp and you should get a new one, right? So our shell is back. Let's see if this file was actually created. And here you can see that this Windows Core Device Info.dll, well, I didn't show you that it didn't exist before, but it exists now. And if you look at the creation time, it was created right now. So our privileged file write definitely worked. And it doesn't seem that the port is actually open. So let's just try that again. And there seems to be some kind of error. And I think this is the case because there's still pending updates on the box. I'm not sure. We could check later with RDP, but at least this is what we originally planned as the priv risk, and you would get an open port here, which you could connect, and then you would have system. But as this is not working, let's look for an alternative way, right? So what I used instead now is this WerTrigger exploit by SQLi, and this basically involves the exact same steps. It's just another DLL that you place that can be exploited. So you go from a privileged file write to a system shell. So basically you have to copy these three files over, and then for the phone info DLL, you just repeat exactly the same step we did for the Windows Core Device Info.dll file. It's exactly the same step, but I will make a short note on the blog post to this video so you can copy paste the steps if you want to. And basically, if you run it as soon as the DLL is placed there, you get a shell, which is kind of a pretty annoying shell if you use it from XC because it kind of doesn't react to everything properly. But it's enough to read the flag, right? You can see that it's kind of messed up here for some reason, but it's enough to print a username and get the flag. So basically we are done now with the box. Yeah, I'm sorry that the USO DLL loader way didn't work, but there are some pending updates on the box. And as soon as you have these pending updates, it won't work anymore. But this WerTrigger variant is fine as well, right? And there's also another way you can escalate privileges if you look at the named pipe communication between the server and the client binary. You will see that you can actually write to the pipe yourself to get an arbitrary file and read the root flag that way. And this named pipe way is kind of also intended. I left both ways open just to have an option in case this DLL file write would somehow be a problem. And as it turned out, it was a pretty good idea to leave the other way in as well. So again, thank you for watching the video. If you like the video, please subscribe, click the like button. And there's also a blog post, like I mentioned earlier. So if you want to see all the steps again, or maybe just the last part, Feel free to check out the blog post in the description. And that's it from my side. See you next week.